have an angle over here as well, and its reference angle is going to be 30 degrees, so you get 150 degrees. And so this one's going to have some, and you just keep adding 360 to those values. So this one's going to have a weird answer of 30 plus 360 in, and 150 plus 360 in. So it has two answers on that one. Alright. Alright, here it's asking for the absolute extrema. Absolute extrema are on a closed interval, and if you notice this right here, this is an x value and an x value. They aren't ordered pair x and y, it's both x values. So what we're going to do, we're still going to find the derivative just like we would before. So if we find the derivative, this is a linear equation of 15x minus 10. Some of you are probably like, ooh, let's do product rule. Well, there's no x here, so you don't need to. So derivative is 15. So, critical numbers, we're going to set that equal to 0. Does 15 equal 0? No. So there are no critical numbers. And if you think of a linear equation, it doesn't have a high or low. It doesn't have any wholes or asymptotes, so that's why you don't get any critical numbers. So this one's kind of silly, but we're going to figure out what the y values are at our endpoints of our window here that they want us to look at. So we plug into our original, and when we plug in negative 3, we get negative 55. And when we plug in 5, we get 65. So we have negative 3 and negative 55, and 5 and 65. So which one has the higher y value? Well, the 5 does. So that is our relative. Yes, relative. Because it is not relative. This is just a minimum, or maximum, excuse me, maximum, because it is on a closed interval, so it's just asking for a maximum or a minimum. If it was on an open, that's when we'd say relative maximum. And then this one is a minimum because it has the lower y value. Alright, so if we find our critical numbers here, go ahead and do that. We get 4x plus 5 for a derivative. Set it equal to 0. And you get x equals negative 5 fourths. Plug in, and you get the y value of negative 9 and 1/8. So here is a critical number. We're going to label it as a critical number. And I always write C number. You can write the whole thing out if you'd like. Alright, so this critical number is between our endpoints here of negative 2 and 2. So we want to look at our endpoints and get their y values. And we get negative 8. So negative 2, negative 8. And then when we put in 2, we get 12. So 2, 12. If we look at all three of those values, which one is our lowest y value? The critical number. So that is our minimum. Which one has the highest y value? The 2. So that is our maximum. Hope you're writing down lots of questions for me. Alright, we are cruising right along. So our next equation is x cubed minus 2x squared plus 8. So what we're going to do there is find the derivative. 3x squared minus 4x. Set it equal to 0. Factor out x. So, set each factor equal to 0. Solve. Here are your two critical numbers. Find the y value by not plugging into the derivative, but by plugging into the original. And you get 8 and 6 and 22 over 27. So we have a critical number at 0, 8, and a critical number at 4/3 and 6 and 22 27. So now we're going to put in our end points. So we got negative 2 and you get y equals negative 8. And we put in 2, and we get y equals positive 8. So we got negative 2, negative 8, and 2, 8 for our endpoints. So which one has the highest y value? Well, this one and this one both have 8, so we're going to call both of them our maximums. They tied. And our lowest y value would be this one, so it is a minimum. So this one wasn't a minimum because we had that endpoint that was lower. So, alright, let's try another one. From here, we got 10x to the half minus 5x. So, of course, let's do the derivative. So we get 5x to the negative half minus 5. So I'm going to set that equal to 0. And I'm going to go ahead and simplify that 5x to the negative half. And if you solve for x, we're going to have to move that 5 first. Then we multiply by our denominator. We divide by 5. And then we square to get rid of a half power you squared. So you get 1. So at x equals 1, something is going on. So we're going to plug in the 1 and get a y value of 5. So at 1, 5, we have a critical number. Since we got a fraction for our answer, for our derivative, we have to ask ourselves what makes this undefined. So 0 will make that undefined, so we have a critical number at 0. If we plug 0 into our original, we get 0. Alright, for our endpoints, we got x is 0 and y is 0. We have x is 1, and if we plug in, we're going to get 5. We've already done that. Our endpoints are the same as our critical numbers. That's crazy. Alright, so which one is our minimum? We're going to go with the 0, 0. And our maximum is the 1, 5, because 5 is bigger than 0. Alright, let's try another one. Yay, we got a quotient rule 1. So for the quotient rule, we got low, derivative, high, derivative, crisscross. So you got 4t on top over t squared plus 2 quantity squared. We're going to set that equal to 0. It is a fraction, so we are going to have to worry about undefined values. What makes the denominator 0? Nothing, because you're squaring something and then adding a positive, so it's never going to be 0. So we don't have to worry about that, but we do have to solve for t here, since we set it equal to 0. So multiply by your denominator, and you get 0 equals 4t. From there, solve for t, and you get 0. So when t is 0, y is 0, or h, I guess, in our case. It says h of t there. So we got 0, 0 is a critical number. We plug in negative 1 for x, because here's our endpoint. If you plug in negative 1, you will get 1/3. And if you plug in 5, you'll get 25 over 29. So our high value is the 25 over 29. And our low value is 0. And that is how you find relative maxes and mins, and just maximums and minimums. So hopefully you come with a lot of questions on the 4th, and I hope you have a wonderful Christmas break.